We can also say that you are able to factor by grouping. Do be aware, it's not very common. If a polynomial has 4 terms, it may be factored by grouping. 1. Factor the first 2 terms and the last 2 terms. 2. Factor out the greatest common factor, the GCF. In this case, our example is 50x to the third plus 125x squared minus 8x minus 20. Let's copy down. So we have 50x to the third plus 125x squared minus 8x minus 20. The first thing we gotta realize, if we have something this big, let's try to see, is there anything common between the terms? Well, we can see that the first 2 terms sort of seem to be similar, I would say, maybe. They sort of look similar. And the second set of terms, therefore, they look sort of similar as well, but not quite, right? But the first 2 definitely do look similar, agreed? So therefore, we'll group the first 2 terms and then group the second 2 terms. And now let's see if there's anything in common. I'll split them up. That way it makes it easier for you to see this. So splitting them up, you don't have to, but I have in this case, that way it makes it easier to visualize. We have as the first split up 50x, let's not forget the exponent, third, 50x to the third plus 125x squared. And we always start with a set of parentheses. And I'll start with just one parenthesis in case I need to make it bigger. Couldn't hurt. If you start with a small parentheses, you may run out of space. So I'll start with just one-sided parentheses for now. What do both terms have in common? 50x to the third and 125x squared. Well, 50 and 125. What are they both multiples of? 50, think about it like 50 cents. And 125, $1.25. Hey, would you say they have a quarter in common? Or 25 cents? Or 25? Well, yeah, they're multiples of 25, so that's what they have in common. Not only that, but both of them have x's. How many x's are in common? One has 3, the other one has 2 of them. So they have 2 x's in common. There we go. So 25x is what they have in common. This is our greatest common factor between those 2 terms. Let's see what remains. 25 times what gives us 50? 25 times 2, right? And then we factor an x squared from x to the third, so that leaves us with just 1x. So we have 2x is what remains. So if you multiply 25 times 2, it gives you 50, and x squared times x will give you x to the third. Let's see, 25 times what gives us 125? 5, right? 25 times 5 gives us 125. And we factor our x squared from x squared, so there's no x's left. So that just leaves us with plus 5. And let's close our parentheses. There we go. So it looks like we factored this one, or at least this half. Let's go for the other half. One set of parentheses once again, and what multiple? Well, they don't have x's, right? Only one of them has x's, so they don't both have x's. Only one of them has an x. But they both have a negative, so we can factor a negative sign from both. What multiple do both of them have in common? So let's see, 8 is a multiple of 4, and 20 is also a multiple of 4, agreed? So we can factor out negative 4. So negative 4 times what gives us 8? That we have 2. And notice that we left the x in there, right? Since we didn't factor out an x. We can't factor an x. 20 does not have an x. So we factor out the negative sign. So that means that it has to be positive, right? 4 times what gives us positive 20? 5, right? There we go. And if we distribute, negative 4 times 2 gives us negative 8x. And negative 4 times 5 will give us negative 20. Yeah, that works. So in that case, let's close our parentheses. There we go. We factored that out. Notice we factor out separately. Hey, look at that. What do you notice between both factored formats? Anything that you notice by any chance? Look at that, 2x plus 5 on both of them, right? They both contain a 2x plus 5. So in that case, the greatest common factor between those 2 separate terms now is 2x plus 5. So let's bring out another set of parentheses, and let's say we factored out the common 2x plus 5, there we go, 2x plus 5 factored out to the front. And now what remains? From 1, we can tell that there is a 25x squared. Let's bring it over, 25x squared. goes from the left side term, and also a -4 from the right side terms. So there we go. That is what remains. We have a completely factored expression now. 2x plus 5, which we can't factor any further, and 25x squared minus 4, which we can't factor any further. No common multiples inside each set of parentheses, agreed? So that is our answer for this particular case. How about we go through a quick check, just a real quick one. That means we're expanding, agreed? So we factor, we want to expand it. So let's just write down our factor format. There we go, 2x plus 5 in one parentheses, or set of parentheses, the other one 25x squared minus 4. And we're basically just distributing 2x, or 2x times 25x squared. Well, 2 times 25 gives us 50, agreed? And x times x squared gives us x to the third. There we go. And 2x times -4. 2 times 4 is -8. -8x. There we go. And let's go for the second term, the 5 times everything in the other parentheses. 5 times 25x squared. So 5 times 25 is 125. And there's just an x squared. So plus 125x squared. And last but not least, 5 times -4. 5 times -4, -20. All right, looks like this worked. Final answer then, we just combine or simplify as possible. Well, in this case, we're just reorganizing so that we have decreasing exponential order. 50x to the third is first, highest exponent, the degree is 3, right? Lead coefficient is 50. Plus 125, x to the second, that one follows because of the x squared, minus 8x, does not have an exponent, but you could put a 1 there, minus 20. No exponent in that one, right? So it looks like we got exactly what we originally started with. 50x to the third plus 125x squared minus 8x minus 20. Yep, we got the same answer as what we started with. So it looks like that is our factored form in the middle there. It's our correct answer.